Hello everyone and welcome to the Reigning Grades Kingdom. My name is Elle and today is all about recombination mapping. But before we get into the video, make sure you go downstairs and click that like button, and also don't forget to subscribe so you can be notified whenever I post new videos. So without further ado, let's make it boom. Recombination mapping is locating the certain loci of genes on a chromosome. But why is that important? Well, the more we understand about chromosomes, the more we can understand about their structure and function and evolutionary predecessors. Now, what's a loci? Well, that's the exact spot on a chromosome where a gene is located. And with that out of the way, let's get on to the steps of recombination mapping. Step number 1, look at your offspring. More specifically, look at the ratio of your offspring. A 1 to 1 to 1 to 1 ratio signifies genes that are not linked, but we're mapping ones that are. Once you discover that your genes are in fact linked, then you have to look at the numbers of your offspring, and the genotype with the most offspring is the same as the parental genotype. And the parental genotype dictates the side of the chromosome that the alleles are on. For example, if I had parental genotypes such as these and plotted them on chromosomes, you could see that the parental genotypes stay on the same side. Same with the second example. Step number 2, find your recombination frequency. This is the measure of how frequently two alleles are separated during crossing over. So you find this by taking the total amount of times they did cross over, or the recombinance, divided by the total amount of times in general. Psst! If there's more of them, they probably did not recombine. This is because it is improbable for crossing over to occur between two close together linked genes. Now let's look at an example. Let's say I obtained these results in an F1 generation. Since I know that the recombinants are going to be the least frequent, I can add the 50 and 42 and divide it by the total to get a percentage of 4.48. This proves that the genes are linked because it shows it is very unlikely for recombination to occur between the PR and VG genes. Step number 3, find your mapping units. Once you completed step 2, this is super easy because mapping units equal recombination frequency. So as you can see here, we have 4.48 MUs, or mapping units, or CMs, centimorgans. What this means is that if you were to map PR and VG, they would be approximately 4.48 mapping units apart. But how will this help us with mapping? Well, let's go over another example. Let's say that we are given genes A, B, and C that are arranged in a linear fashion as noted by scientist Sturtevant. Now, let's say we are given that the distance between A and B is 3 mapping units, and the distance between A and C is 6 mapping units. Well, there are 2 different ways we can map this. So we could either map it A, B, and C with 3 mapping units between B and C, or C, A, B with 9 mapping units between C and B. The real mystery here is the distance between B and C, and once you know that, you can correctly map it. A highly effective way to correctly map genes is through a 3-point test, and if you want me to do a video on that, make sure to leave a comment down below. Thank you so much for watching this video. I hope that I helped you get an A on your test. Much love always from Elle, and I'll see you again soon in the kingdom.